This is the subplans for block day on Wednesday. So what you're going to do is just leave this here for like the first 5 minutes of class. When they're done and ready, press play again, and now I'm going to go over the answers. Okay, so we're converting each of these into general form, So if you don't remember what general form is, this is where we want to get out our pink packets from last unit and look at what general form is. General form is always in the form of y equals ax squared plus bx plus c. You could have minuses though. So here all we're going to do is we're going to FOIL and then FOIL again. So then we're going to get 2x squared minus 2x minus 8 here. Same thing. First we have to FOIL this individually, x plus 5 times x plus 5. Then bring in the 3. Multiply that all and then subtract a 10 to our number. So this was a 75, and then you subtract 10, making it 65. Convert each of these into factored form. So now they look like this. This is where we're going to do that box thing. So if we were writing, a lot of you like to do this, or you're going to do the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You could also do that one. So box or this. It's going to give you this answer. So we're going to get x plus 12 and x minus 7. This one, we can pull out a 2x. And then we have left x plus 6. All right. So this is for everyone right now except for Natalie. Natalie, you know what you're doing. Go do it. So we're taking out, there it is. We're taking out our purple paper that I gave you yesterday. If you don't have one, I have some up by where I normally stand on that desk. There's 2 little pieces of purple paper up there. If you need one, I only have 2 left. Go ahead and grab it. So equations, we already filled this in. Linear is going to be y equals mx plus b, where it's just 1x without a value. Quadratic would be y equals ax squared plus bx plus c. The main thing being that there's an x squared term, and our exponential y equals a times b to the x, where it's something to the x power. So for our table, I'm actually going to skip the table right now. I'm going to come to this one last, probably. For our graph, graphing is pretty easy. Graphing for linear, if I have a graph, something that's linear is going to look like a line. Linear is a line. So all we're going to see, if it's linear, and I'll do this in red, is we're going to have something like this. It's a straight line. It could be this way. It could be this way. It could be over here. It could be. It doesn't matter as long as it's a straight line. Linear line. Quadratic. A quadratic is always going to look like a parabola, so it's going to be something like this, or it's going to be something like this, right? It's a parabola. Exponential. There's 2 different ones that we have here. We can have an exponential growth where it's something like this, or we can have an exponential decay where it's like this. So it kind of looks like it's half of a parabola where it's missing the other, it's missing the other parts. So the graphs are easier. Right now we're going to work on tables. We're going to do story problems probably later. Actually, we'll fill in this whole graph today and we'll do tables probably tomorrow. That'll be fine. So with tables, so what I want to say about tables, let's see my pen. I am. So for tables, blah, 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 whenever you have a table, and I'm going to show you examples for this. So you either can do the examples or an example on a different piece of paper. Linear, when you're finding the difference, remember whenever we have a table, x, y, so maybe I'll write this here, x, y, and I want to find if there's numbers all down here, I'm finding the rate of change. They're all going to be constant if it's linear. It's going to be a constant rate of change. If I were to do this same thing for an exponential, it's not going to be, so this one I would be adding plus 3, plus 3, plus 3, or whatever. This one is going to be a multiplier, right? This one wouldn't be adding. When I'm finding it, I'm multiplying it by 2, or I'm multiplying it by 0.7, or I'm multiplying it by something. So for me, it's easiest to find these 2, and whichever one is not fitting these 2, then it would be quadratic. Another way that you could think of it for a quadratic is, and this won't make sense until I show you, is that it's not constant the first time, but it is constant the second time. So what I'm going to do right now is I'm going to show you examples of what I mean for these tables. So I'm going to, and you don't have this in your packet, so you're going to have to copy it down wherever I find it. Here we go. So example 1, here's a table, right? Here's a table. And what I mean by the differences, so I'm going to try and find that constant rate. So my changes in x, I'm going up 1, up 1, up 1, up 1. The entire time I'm going up 1. The entire time here I'm going up 2. So when I find my rate of change, it's a constant 2 over 1, 2 over 1, 2 over 1. So it's constant. So in my table, it's constant. I'm always by what I'm adding. For this one, I'm adding. I'm not multiplying. There's nothing negative 3 times something that's going to give me negative 2, and that same number that I multiply by will also give me negative 1. So this one is going to be linear. This one's going to be linear. Also, you could graph it, and you can see that it's a line. So this one is what I mean by the constant rate. It's going up by a same number. I'm going to jump now to quadratic. So what I mean by here is if I look at this, this is, if I'm trying to think of it, 9 times some number can give me 4, whatever that is. So I can get out, so this would be 9 times 0.11111, but that times 4 does not give me 1, so it can't be a multiplier. So 9 times 0.1 gives me 4, and then 4 times 0.1 gives me 4.4. So this can't be exponential. So if I look at quadratic, I want to see what I'm adding or subtracting. So 9 to 4, I subtract 5. 4 to 1, I subtract 3. 1 to 0, I subtract 1. It's not constant. I'm not getting a constant thing here. So if I look up here, this is going by ones, plus 1, plus 1. So I'm getting negative 5 over 3, negative 3 over 1, negative 1 over 1. It's not a constant rate. But the second time I do it, so if I look at my rates between this now, to get from negative 5 to negative 3, I add 2. To get from negative 3 to negative 1, I add 2. To get from negative 1 to 1, I add 2. Do you see how this is now constant? That's what I mean by the second time around. So the first time it wasn't constant, but the second time it is constant. This one takes a little bit more work. That's why I normally say, hey, find linear, then find exponential, and then whatever is not linear and exponential is quadratic. But this is what I mean by that. And again, if we graph this, we see that it's a parabola. And then this one. So this one, I don't like this way that they think about this. So to get from one y value to my next y value, I am just multiplying it each time. To get from 1 to 2, I times by 2. To get from 1/8 to 1/4, I times by 2. 1/4 to 1/2, I times by 2. 1/2 to 1, I times by 2. 1 to 2, I times by 2. Times by 2. Times by 2. Times by 2. This one is the only one that's using multiplying. The other one, so if we look back, adding, adding. This is the only one that's being multiplied. So this has to be exponential. And if we see, do you see how it's like half of a parabola? So this one would be exponential. So we are going to practice this. Actually, right now we'll practice just 4 of them, and then we'll do the focus problems. All right. So if we look at these two, so what I want you to do is you can pause the video again from before if you needed to, rewind the video, pause, let them do whatever they need to do. Pause it, let them work on it, play it when you're ready. All right, number 1. So again, these are all moving at a constant rate of, this is plus 1, plus 1, plus 1. I'm not really worried about the x values when I'm trying to find these. I'm more worried about the y values. So let's see. To get from 14 to 10, I minus 4. 10 to 6, I minus 4. 6 to 2, I minus 4. 2 to negative 2, I minus 4. So I'm moving at a constant rate, and I'm going down by 4. So this is going to be linear because it's constant. Linear because it's constant. Over here, again, the x's I don't really care about. I'm adding 1 every time. I don't care. So here, from 1/2 to 1, I can either say that I'm adding a half, but if I do that here, 1 plus a half would be 1 1/2. So it can't be adding. I know right off the bat it can't be adding because 1/2 plus 1/2 is that 1, but 1 plus 1/2, this should have been 1 1/2, so it's not adding. But I can maybe look at, so this is 1/2, 1 to 2 is 1, 2 to 4 is 2, 4 to 8 is 4. So then maybe I can think of here, is this all constant? 1/2 to 1 is a 1/2, 1 to 2 is 1, 2 to 4 is 2. See, it's not, this one's not constant. To be a for quadratic, it has to be the first one is not, but the second one, this row would have been. They would have all been 1/2s or all been 2s. So I know it's not quadratic. Again, I could have just, once I checked addition and see if it was constant, I could have went straight for multiplication. If that didn't work, it would have been quadratic. So here, I'm multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this, again, would be a exponential. If I wanted to, I could write equations for both of these, right? My equation here would be in the form y equals ax, nope, not doing this, y equals a times b to the x. A is my starting value. My starting value is always where my 0 is. What goes with 0 is 4. My multiplier, I'm multiplying everything by 2. This would be my equation. Over here, linear is y equals mx plus b. b is where I start. That's where my y equals 0. So that's a plus 2. It's a positive 2. My rate of change is I'm going down 4 over 1, so negative 4x. That would be my equation here. It's linear because there's one x value. This is exponential. It has a number to a power. So now that you've tried these two, we're going to work on some focus problems. So you can listen to music. You can work with a group. I'm going to leave my teacher edition book up there so you can go up there and check your answers whenever. So this is just kind of working on linear and exponential more so that way we can manipulate them. So I'm just going to write them down. 400, number 1. Page 415, number 7. Page 161, number 2 and 8. Page 168, number 2 and 8. Before you do these problems, you can go on a break, like a quick 5-minute break. Page 182, number 2. Page 337, number 3. Page 345, number 2, 3, 4, 5, and page 377, number 2. So in case you can't read this, 400, number 1, 415, number 7, 161, numbers 2 and 8, 168, 2 and 8, 182, number 2, 337, number 3, 345, 2, 3, 4, 5, 337, number 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I expect for you to have at least 7 of these problems done. And I am checking tomorrow. 7 or more. If you do not have 7 done, I'm not counting you at all for any credit. You need to have 7 done to count for any credit. Alrighty, that's what you're working on today. Bye.